Hi, I'm Milan Gandhi. We have developed a fleet planning assignment tool. This is an executable which we need to open. It will take a couple of seconds to activate. The tool is activated. It consists of two applications, fleet planning and fleet assignment. Fleet planning can be evaluated by two approaches. Top-down approach, that is macro level, allows for the rapid evaluation of aircraft types given the high-level assumptions such as changes in traffic forecast, operating costs, for example, changes in the fuel price, airline structural changes such as average stage length of flights. The bottom-up approach is a micro level which uses substantially more detailed data such as 10 to 15 years of scenarios which are highly speculative. We have opted for the top-down macro level fleet planning approach. Let's start. Let's assume a particular airline wants to lease an aircraft for a period of 2 years. For this purpose, they need to evaluate different kinds of aircrafts which would contribute to the profit of the would contribute the profit for the airline. So it's a long haul route, it's a non-stop, and it's got a high demand. So let's assume that the origin for this route is Boston and the destination is Rome, and as we want to evaluate the particular aircrafts, we will be choosing 3 aircrafts out of which the better performing aircraft would be chosen. So we need to plan it, and we are going to have a monthly plan for that. We will plan it for a month, 1 month, say from 1st April 2020 to 30th April 2020. So we would evaluate 1 month's cost, 1 month's revenues and the operating margin for the 3 different aircrafts which we have the alternatives for. So let's submit. Say the airline has targeted the utilization per day of that particular aircraft should be 12 hours. Passenger yield per RPK is say 0.88 is estimated for this route. Fuel price per gallon, say it's $3.50. Average passenger demand per flight, that is unconstrained demand, is say 245. Based on the demand, the RPKs, the passenger yield would be calculated, and the aircraft types would be, say, we have B767-300 ER, we've got B777-200 ER, and we've got Airbus 340-500. These are the available alternatives for the airline to choose from for this particular route. And then the fuel burn per block hour, say, is for this aircraft is 1815. For this aircraft it is say 2100, and for this is 2345. These are the fuel burn for per gallon per block hour in gallons. So the seats for this seat configuration is say 269 for this aircraft, 305 for this aircraft, and 325 for this aircraft. And when we click on submit button, the average block hours will be calculated per flight leg, block hours per month, and the departures per month of the flights. So let's submit. There is a field empty. Average stage length is 7,500 for all this for this route. So the aircraft has to fly this 7,500 kilometers. Now we input all the data. Let's submit, and we're getting the average block hours to be 9.8 per flight leg. Block hours per month is 360, and departures per month is approximately 37. So this will be in the formatted manner. When we generate the report, we'll get the precise figures. Let's move to the next screen. Here the ownership cost we have to enter. We are calculating the monthly fixed cost. So for that, the ownership cost for 3 aircrafts is different. So we say, let's say 320,000 for this aircraft, 335,000 for this aircraft, and 365,000 for this aircraft. And maintenance burden per month would be say $150,000 for this, 145 for this thousands, and 140,000 for this particular. So this is the monthly fix. So what we'll be deriving the total fixed monthly cost per aircraft, and then we'll get the fixed cost per. Based on that, we'll be getting the fixed cost per block hour. The variable costs are there for crew. Let's say for this aircraft is 1,010. For this aircraft is say 1,215, and for this aircraft $1,325 per hour for the crew. And fuel will be calculated automatically. The maintenance per block hour for this aircraft is 660 for say $540, and this would be say $510. So these are the estimates for the operating cost. The airline have estimated this particular figures, and then when we click, we'll get the variable cost per block hour. Based on all this, we'll be getting total aircraft operating cost per block hour, fixed and the variable, and then the total monthly aircraft operating cost will be calculated when we hit the submit button. So these are the figures being generated, which we'll see in details in the formatted way in the report when the report is generated. Let's move to the next screen. Here the cost per departure for aircraft type 1, what we choose is 1,750 say, and 1,950, and this is $2,020 for the cost per departure. These are the cost per departures, and then it will, when we input this and hit the submit button, total monthly cost, that is aircraft servicing cost, would be there. In the passenger cost, we'll be calculating the average passengers per flight, average load factor, and total passengers per month. We click on this, and here we are. We got this particular figures, and we will discuss about this particular average load factor for when we generate the report. Click next. Here the traffic servicing per passenger is say $25 for each aircraft, and passenger servicing per RPK is say 0.020, that is 2 cents of RPK, 0.020 for all the 3 aircraft types. That's 2 cents, and once we hit the submit button, the total RPKs, total ASKs, monthly traffic for traffic servicing monthly and monthly passenger service would be calculated, total monthly cost, and based on the monthly cost, the unit cost per ASK will be calculated. Let's submit. Here we are, and let's move to the next screen. Here we enter promotion and sales, that's on the percentage of gross revenues. So say 9% of the gross revenues you would be taking for sales and distribution expenses for the 3 aircrafts, and here the average yield which we input in the first screen would be displayed, and then the gross revenue less the promotion and sales will give the net passenger revenue, and the additional passenger revenues is say 455,000 for this particular aircraft, 562,000 for this aircraft, and 645,000 for this aircraft. So based on this, we will be generating gross revenue, net revenue, and we'll be having total revenues, operating contribution, and operating margin when we hit the submit button. So here it is, and here we can see the figures. Now we want to see it in the formatted way, with the dollar sign, with the percentage sign, with the decimals, and all the formatting specifications needed. So let's click on the generate report button. Here we are, report is generated successfully. Click OK. Let's go to the folder from where we have executed the where we have started this thing by executing the executable, opening the executable, and here is the report being generated. Fleet planning report will open to see the detailed report in a formatted way. So this is what the origin and destination we were evaluating for 1 month from April 2020 to April month total. So 34,200, currency type is USD. These are the inputs we had entered in the user interface, and these are the aircrafts chosen, and this is what the yellow cells are the ones where we input all the values, and the white cells are the ones which are calculated. So we can see the average block time 9.85 for a flight leg, then 360 hours per month the block hours, and then the departures per month is 37. This is where the input field for seats and the fuel, and this is what we input for the ownership and maintenance, and the calculation total per aircraft. This is fixed cost per month we are getting this, and then based on the fixed cost we are getting the fixed cost per block hours. The variable cost, we input the crew and maintenance. Fuel was automatically calculated, and the variable cost per block hour was calculated. Based on that, the total aircraft operating cost per block hour, and then the total monthly aircraft operating cost was calculated. So the cost per departure was this much, and so total monthly cost would be this much. So average passenger per flight is 229 for this, and 245 and 2. Here the thing is, average passenger is 225. This particular is just to be make sure that the average load factor does not exceed 85% because of the seasonal. There is a variability in seasonal demand. So it cannot exceed 85%. The average load factor here is 80%, and here it is 75% for this aircraft. So it's made sure that the average load factor does not exceed 85%. So this was a point to be made because of the varying seasonal demand. And then the total passengers per month, total RPKs and ASKs calculated. We entered the $25 for the traffic, and then passenger service per APK 2 cents, and then based on that the monthly traffic and monthly passenger service is calculated. Total monthly cost, unit cost for after getting the monthly cost. Then the passenger revenues, you can just see the yield which we entered was 0.88 cents, so that is 88 cents, and this was the 9% of the gross revenue calculated. The gross revenue was this much, less this particular 9% of the gross revenue, and we're getting the net passenger revenue, and plus we are adding the additional cargo revenue. So the total revenues come for this much, and the operating contribution and the operating margin for three types is 10% for 767, 777 has B, 777 has 8%, and A340 has got 4%. So ideally it should be 10%, or B767 should be chosen to fly over this particular non-stop or non-stop daily route Boston to Rome, and as it contributes its highest contribution towards the profit. So this is the way for a particular month particular aircrafts have been planned to evaluate the cost, revenues and the operating margin. So this was fleet planning, and now let's go back to our user interface and go to the second application. Let's go, click home, we've got here, and now we'll go for the fleet assignment. Let's start. Let's assume a particular airline has flown this Boston Rome route last year, that is in 2019, from April to June, and for 3 months they flew, and they operated A330 300, and they want to fly the same route in the same months, that is from April to June. For 3 months they want to fly, and they have got different alternatives of aircrafts, and they want to choose the aircraft type which will contribute to their highest, would be having a highest contribution to the profit. So let's submit this particular. Now the last year when this particular aircraft was flown, A330 300, the airline had observed this particular loads. So let's see, the capacity for Y class was J cabin was 28, and the capacity for Y cabin was 261. So, and the mean load was say 22.7 for the J cabin, and for Y cabin 78.1%, and the standard deviation was recorded was 7.5, and this was 78.1. Now this were the observed loads for the 90 operations, that is the 3 months which A330 300 flew in 2019 in the peak hours, peak summer time. And now this were the observed and the recorded loads. So based on this we will get when we submit we will have the average load factor. That was this was the average load factor. Oh sorry, there is a figure wrong input here. This needs to be the mean load for 261 is say 232.9. So now we submit it, and we get the load factor. This is 81, and average load for this one is for 89. And based on this, we will do it will be average load factor will be in consideration for the next step. Here is the estimation. Now for assumed K factor has to be between K factor is the coefficient of variation that is on the higher side for the leisure market, and it's between 0.20 to 0.040, and coefficient of variation for the unconstrained demand. So let's assume, and we'll be using the spill table, and we are using the spill model, the flight leg spill model, to calculate this. So 0.35 would be the coefficient of variation, that's the K factor, and this is input. Based on this, the calculations will automatically done from for the demand factor and spill factor from the spill table. So basically load is equal to load factor is equal to demand factor plus demand factor minus spill factor, whereas the demand factor is equal to load factor plus spill factor. The spill factor is demand minus load, and unconstrained demand will be based on these two figures. This unconstrained demand and the standard deviation of unconstrained demands will be calculated. Then the average spill per flight will be calculated, and spill rate, that is the number of passengers who could not book the tickets from the unconstrained demand. This is from the unconstrained demand, so that percentage would be calculated. See, this is an automated process, and this is a very sophisticated level of process being implemented. So let's hit just the submit button, and at the same time the previously calculated in the previous screen what we calculated, the average load factor will be also taken into consideration. Actually based on the average load factor, it translates to the demand factor calculation and the spill factor. So let's submit, and these are the calculations. You can see the demand factor is 0.972, 0.2122 is the spill factor for both, because we are using the average load factor figures. So we are taking an average of the previous screen, 81% for the J cabin and 89% for the Y cabin. So we are getting an average of 85%. So based on that, the 85% of load factor would give a calculation of 0.972 and 0.122 from the spill table. So it's been fetched from the spill table. Based on this, the unconstrained demand is this, and for this class it is this, and the standard deviation for both 9.5 is almost 10, 88.7, that's 89, and then the average spill per flight is this much, 3, and this would be something like 32. When we generate the report, we would see these figures because we are using this particular aircraft, that is A330-300, also in the evaluation. So spill rate has been calculated, is approximately 13% of the unconstrained passengers, unconstrained demand passengers who could not buy the ticket. So this is the spill rate. Based on this, now we go to the next screen. We enter the spill and profit analysis per flight we want to calculate. We just put this the same coefficient of variation for, this is basically for the leisure market, on the higher side 0.3, 0.35, and then the net revenue is 675, and this is 310. Okay, so when we hit the submit button, we'll get the unconstrained demand, and this is the unconstrained demand, 27 point this thing, and 253 for this, and this is for the aircraft A330-300, which we have observed the loads. Let's move to the next screen, and we'll here input the three. We've got an alternative of inputting three different types of aircrafts, where the airline would choose from which aircraft needs to fly this particular route for this summer. So the aircraft type say is A330 200. Here is A330 the 300. This was flown the last year, and here say B777 300 ER. Now the capacity, the J capacity for the 330 200 is 22, and this is 228. And then here it is 28 and 261. This is what was flown the last year, and based on this particular aircraft only we got the estimates in the previous screen. And then this is 28 for B77, and this could be say 309. Flight operating cost per hour would be say 6,450. This one would be 7,300, and this one would be 7,740. So on this, and the flight leg is Boston, Rome. The distance is 8380 kilometers, and the block time is say 10.6 hours. The J cabin for the passenger revenues would be, net passenger revenues would be, this is $675, and this is $300 for this cabin. And here all the net of all the variable costs, that is traffic servicing, passenger servicing, sales and distribution, will be taken into account. Now we submit here, and we go to the next screen, and here we need to enter the load factor for the business class. So and the aircraft type. So once we enter the load factors, the demand factor, the spill factor, the spill and average passenger load for this particular class, J class, would be calculated. So 0.85, if it is 85%, you need to write input 0.850. We will take this as a constant 85% of the load factor, 0.85. And when we hit the submit button, we'll get all the calculations which we'll see in the report, and based on this particular figures we would be choosing the different aircraft type. Now let's move to the next, and for economy class, that is Y cabin, so we will be inputting the same 0.85, load factor 0.85 and 0.85. Once we hit the submit button, the same way for the previous the cabin, which was business class, was calculated, the same way it will calculate the average passenger load for that class, demand factor, and the spill per flight. Basically these calculations are done basically for a flight, so spill per flight will also be calculated. Submit. So these are the calculations. We'll look into it in the next screen. And here when we just hit the submit button, we'll get the net revenue, flight cost, operating cost, and operating margin. And based on this, the evaluation will be done. So let's submit, and this is what is derived, calculated, and we'll see which aircraft is having the highest contribution to the profit. So to see the formatted report, we'll just click on the generate report button, and the report generated successfully. Let's go back to the same folder from where we started our this tool and the applications. So here you can see fleet assignment report. Fleet planning report was generated when we executed the particular application. Now we executed the fleet assignment application. The report is generated. Let's see the detailed report. So this is a detailed report. We wanted to fly this particular route for 3 months time, and we've got this particular previous observed loads of 330, 300, and average load factor was this. Now it's in the formatted way, so 81% and 89, and when we combine 81 and 89 we get 85% of the average load factor. And this was the coefficient of variation, and this is the demand factor, spill factor from the spill table, and unconstrained demand was calculated, and the standard deviation of the constraint plate power. Now the average spill per flight was for this particular aircraft was 3 and 32, which we'll see in the later part also, and the spill rate was 13% for both the cabins. Now this figure will be repeated as we are going to take into consideration this figure of the unconstrained demand. So the unconstrained demand, this 227 and 254 was there, taking the coefficient of variation and the net revenue. So this was automatically calculated based on this particular inputs. And now we will look at the aircraft types, what we input the different aircraft types with the capacities, different capacities with the different operating flight operating costs per hour, block hours. This was a block hour, and this was a kilometers flown, and this was a route, and these are the YJ cabin, Y cabin passenger fares. This is a prorated fares. Now these are the three, and when finally we look at it, this particular aircraft is first aircraft 330-200, which has got the capacity of 22, has got a demand factor of 1.28, and load factor is going to be the same for everything, and which has a spill of 9 for this particular class, that is a J class, and average passenger load is 19. The 22 is the capacity. And the same when we look at it for the Y class, for the same aircraft, 228 the capacity, and the demand factor, load factor is there. The spill is 60, and average passenger for Y class is 194, and basically the seats capacity is 228. Let's go to the second aircraft A330, which was flown the last year, so the stats are there. We had observed 28% seats for this 0.92, and the spill was 3, and the average passenger load was 24. So this was calculated by us, and the same goes for 261 seats for the Y class, and the spill was 32, and the average passenger load was 222. And let's go to the third, the B 777, 28. This were the load factors and demand factor, spill factor. This is the spill, 3 is the spill, and 24 is the average passenger load for 28 number of sitting capacity for this class. And when the Y class had the capacity of sitting capacity 309 and 85%, and the demand factor is calculated, we have got just a spill of 9 passengers were spilled out, and the average load factor, average passenger load was 263 based on the 309 seat capacity. Now let's see the revenues for all this particular 3 aircraft. This is the revenue, flight cost, and operating cost and operating margin for the A300 A330-200, that is 6% the operating margin. For A330-300, which was flown the last year in this time, and the operating margin is 9%, and the B777-300ER, which is here, and it has got the operating margin of 16%. The reason it is having the high operating margin is because the spill is just 9 out here for the Y class, where the capacity is 309, and for the J class it is got 3 number of spills, and average passenger load is 24, whereas the capacity is 28 for the J class. So if you look at similarly, if you look at it for the different classes spill, for the different aircraft, here the spill is for A330-300 at 32 spill. This was a flown aircraft last year, so it has 32 spill for the Y capacity, Y cabin, and it had 3 for the spill for the J cabin, whereas the spill for A330-200 is 60 for the capacity of 228 for a Y class, and 9 is the spill for the J class. So this is the these are the calculations done, and definitely airline would choose B777-300ER with 60% of operating margin, and this would likely to be flown for this particular route for the month of April to June, summer peak time. So this is fleet assignment application and the report being generated. So these are the 2 applications we have developed for this particular tool, and thanks for watching it.